Hey, what's up, guys? So today we're going to use the Pythagorean theorem to find the distance between 2 points. So again, just another way to apply this, what we might more regularly see, is finding the distance between points. So here we go. Sometimes we look and we see, hey, it's just straight. We can just count it, right? Like graph A, I could just count those. And I'm like, oh, from point 1 to 2 right here, I go 1, 2, 3 spaces. Yay. Okay. But then when we get into these diagonal lines, it's not as straightforward. And so now we have to do some calculations. So to find a diagonal distance on a coordinate plane, we're going to create our own right triangle. So we're going to draw that in. And then we'll use the Pythagorean theorem to calculate the distance. Okay. So the diagonal distance that we find would represent the hypotenuse. Remember, that's the longest side of our right triangle, or C in our formula. That's what we're going to practice today. So when we are trying to find distance, we're going to create the right triangle, and then we'll use the Pythagorean theorem, just like you've been doing. So it's just a different way to apply it, right? We have to do a little bit more thought process to it. Okay, so I have points. I have point A and B. Okay, I want to create a right triangle with that. So I can either go up from A or I can go down from B. Either way, we'll have the same kind of triangle. Okay. So I'm just so that we can see it really well, I'll go from B. So I just go down to where it lines up with A, right? There's my nice right angle right there. Okay, so now I know A, B. I'm trying to find that diagonal distance. So now I can find this because I can count straight lines, right? So 1, 2, 3, 4 for A, and then B is 1, 2, 3, 4, 5 for B. All right, once I know that, it's what we've been doing. Plug it in to the formula. A squared plus B squared should give me C squared. So I do 4 squared plus 5 squared equals that side area. Okay, so then I just simplify that. I should know this, it's 16 plus 25, but just to show you in the calculator, right, do 4 squared plus 5 squared, that's going to be 41. Okay, so I'm at 41 equals C squared. Remember, that would be like if I drew a square here, the area is 41, but I want the side length. Remember, side length is found by taking the square root of the area. Okay, that's not a perfect square, so I'm going to jump back into Desmos, square root that baby, and we'll round it to the nearest tenth, so we'll say 6.4. Okay, so that would be my diagonal distance. That's the distance between A and B going on the diagonal. Cool, right? Like, you start thinking about how would I use this, right? All right, let's do it again. So from A to B, we want to draw our right triangle. So I go straight up from B. Okay, I could go down from A and over to B. I'll still get a right triangle. Okay, so I know my legs create the angle, and then hypotenuse is the longest side. I just count. So 1, 2 spaces for A, and for B, I go from here, I go 1, 2, 3, 4, 5, 6, 7. Okay, so I have all the information. Now I can plug it in to the Pythagorean theorem. So A is 2, so 2 squared plus B is 7 squared should equal C squared. That's going to be 4 plus 49. I could do that in Desmos. 4 plus 49 is going to be 53. Oh, that's not a perfect square. Remember, this found the area. We want the side length. We take the square root. Just come to Desmos. Square root of 53. Let me put the right number. 7.28 to the nearest tenth. We would round up because 8 there. So 7.3 is the diagonal distance. Over and over, that's just what we're doing. All right, so I have A and B. Connect them. Draw your right triangle. So remember, I could go here from A over to B, or I could go up from A and over to B. Either way, we'll get the same result. Okay, so we have our legs make the right angle, longest side is the hypotenuse. I'm just going to count. So I go 1, 2, 3, 4, 5, 6, 7, 8 for A, and then B, start here. 1, 2, 3, 4, 5, 6, 7, 8 for B. Once I have that information, it's doing what we've been doing. So my side lengths are the same. 8 squared plus 8 squared is C squared. Okay, that's 64 plus 64, 128 equals C squared. And you take the square root to find that side measurement. Okay, if you're sitting there like, how the heck did I know it was 128? Right, 8 squared plus 8, whoops, 8 squared it's 128, and then we want the square root of that number is 11. We'll round it to 11.3. Okay, so we just found the diagonal length right there, going from A to B. All right, that's what we're doing, find the distance. Okay, so now what if I don't have it plotted? I can plot points and still go and find it, right? So I have -6, 1, -6, 1 right here. Then -4, 5. Just remember it's your x values, then your y, horizontal, then your vertical. So -4, and then up to 5, right there. Okay, so now I can connect, create the right triangle, and then I solve. Okay, A is going to be 2, B is 1, 2, whoops, 1, 2, 3, 4. All right, so this would be A squared plus B squared equals C squared. So I'm going to have 2 squared plus 4 squared equals C squared. Okay, that's 4 plus 16. Again, you could put that into desmos. 4 plus 16 is 20. Okay, that's not what I want. I want the side length, so I do square root. And that's not a perfect square, so let's go see what it's close to. So we can do a rounding here. Root of 24.47, so we'll do 4.5 would be that distance between those 2 points. Okay, that's what this would be, 4.5. Okay, all right, do it again. Okay, so -7, -7, -7, -7, and then we have 4, 3, so +4 down to -3. So practicing plotting our points, right? All right, so I would connect those. I want to make a right triangle. So go across, pretend I'm drawing straight lines because those are horrible lines. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is 11, right? And this side goes 1, 2, 3, 4. So this side is 4. And now I'm ready. A squared plus B squared equals C squared. I keep doing that to remind myself what I'm finding, right? C is what I don't know. I have the other values. So 11 squared plus 4 squared equals C squared. So that's 121 plus 16. Okay, and again, right, 137. Notice you can just jump into Desmos, get stuck with the calculations. You do need to know how to set it up though. Desmos is only as smart as the user, right? Last step, always we want that side length. If we just want C, we need to take the square root. So that's not a perfect square. See how knowing this will help us out? Square root of 137, we're going to say 11.7. Okay, so that's our hypotenuse. That's what this measurement would be, 11.7. That's what we're finding. Okay, we'll do one more. Here we go. 0, 2. So 0, 2 is right here. And then 7, 7, so positive 7 up to 7, it's right there. Okay, we're going to connect. Then you draw your triangle. Okay, again, I could go up and over. I can go over. I just keep choosing what I'm going to be able to see, like the axis. I might get a little confused with that, right? Okay, so here we go. C is what we're trying to find. So let's find our distance here. We have 1, 2, 3, 4, 5, 6, 7. And then we have from here, we go 1, 2, 3, 4, 5. Okay, so now we're ready. A squared plus b squared equals c squared. So we have 7 squared plus 5 squared. Remember that order wouldn't matter. C squared. 49 plus 25. Okay, 7 squared plus 5 squared is 74. Am I done? No, of course not. I need the side length. So square root, and that's not a perfect square. So let's see what Desmos gives us. Square root of 74. We're going to go with 8.6. So that's what this side length would be, 8.6. Okay, that's how we use Pythagorean theorem to find distance between points. Cool.